Ever feel like you're staring at a puzzle, but you're missing some key pieces? Well, that's what we're tackling today. We're going to become puzzle masters and crack the code of linear equations in two variables. So here's our roadmap. First, we'll get a handle on what these equations even are. Then we'll dive into some awesome ways to solve them. And to wrap it all up, we'll see how this stuff actually works out in the real world. Okay, let's kick things off. Section 1. What are linear equations? Before you can solve any puzzle, you got to understand what the pieces look like, right? Okay, think of it this way. Imagine you're a detective, right? And you've got two clues to solve a big mystery. That's exactly what a pair of linear equations is. Each equation is one of your clues. And when you draw it out, each clue makes a perfectly straight line. The big secret? The solution to the whole mystery is just the one spot where those two lines cross.
So with these two lines, there are really only three possibilities. First, they can intersect at one single point. Bam, that's your one unique solution. Or, plot twist, they could be the exact same line, just in disguise. In that case, every single point on that line works, meaning we have infinite solutions. And the last one? They could be parallel, kind of like train tracks. They run alongside each other forever, but never ever touch. And if they never touch, well, there's no solution to the puzzle.
All right, on to Section 2, solving with pictures. Let's get visual. Our first tool is the graphical method, and it's all about drawing a map that leads us straight to the treasure. The answer. So, how do we actually draw these lines? It's way easier than you might think. All you need are 2 points for each line. A super simple trick is to plug in 0 for x and see what y is, and then plug in 0 for y and see what x is. Just like that, you've got 2 coordinates and you can draw your line. And here it is, the big aha moment. Once you've got both lines drawn on your graph, the answer is just staring you in the face. It's the exact point where they cross. In this example here, you can see it plain as day. They intersect where x is 1 and y is 2. And just like that, puzzle solved. Okay, Section 3, the algebraic shortcut. Now look, drawing graphs is cool and all, but what if the numbers are super messy? Or you don't have graph paper handy? We need something faster, something more powerful. And that, my friends, is where algebra comes to the rescue. And we've got 2 amazing algebraic tools in our toolkit. First up is substitution. This is where you basically solve for one variable and then plug that information into the other equation. It's like using one clue to decode the other. Then there's elimination. This one's a really slick move where you add or subtract the 2 equations to make one of the variables just poof, vanish. Let's take a look at substitution in action. So you start by grabbing one of the equations and you isolate a variable. See here? We've just shuffled it around to get x all by itself. Now, you take that whole expression for x and, you guessed it, you substitute it into the other equation. The magic is, now that second equation only has one variable, y, which makes it a piece of cake to solve. And now for elimination. The whole goal here is to be a little clever. You want to tweak one or both equations so that one of the variables has the same number in front of it. In this example, we just multiply that top equation by 2, and suddenly we have 2x in both. Now for the cool part, subtract one equation from the other, and the 2x terms just cancel out. Poof, the x is gone, and you're left with a super simple equation with just y in it. All right, Section 4, the no graph check. I love this part. This is a total pro tip. It's a secret trick to figure out what kind of answer you're going to get, 1, none, or infinite, without doing any of the heavy lifting. Seriously, what if you could just glance at the 2 equations and instantly know if the lines are going to cross, run parallel, or be the exact same line? Sounds like a superpower, right? Well, you can totally do it. Okay, so here's the secret code. It's all about comparing the coefficients, the numbers in front of the x's and y's, and the constants on their own. You just turn them into ratios or fractions. And check this out. If the ratio of the a's isn't the same as the ratio of the b's, you've got intersecting lines and one solution. Guaranteed. If all 3 ratios, a's, b's, and c's, are identical, that's the same line, infinite solutions. And if the first 2 match but the last one doesn't, that's your telltale sign for parallel lines. No solution. Okay, let's try it out. First thing, you got to make sure the equations are lined up in the same format. Now let's check the ratios. The x's give us 1 over -3. The y's give us 2 over -6, which, hey, simplifies to -1/3. So our first 2 ratios are a match. But look at the constants. That ratio is different. Ding, ding, ding. That's our secret code for parallel lines, which means no solution. And we figured that out without a single bit of graphing or heavy algebra. How cool is that?
And now for Section 5, Equations in the Wild. You've got the tools, you've learned the tricks, now let's put them to the test on some actual real-world puzzles.
First up, a classic cost puzzle. Check it out. 4 pens and 4 pencil boxes cost 100. That's our first clue, our first equation. 4x plus 4y equals 100. The second clue? 3 times the cost of a pen is 15 more than a pencil box. That becomes our second equation. 3x equals y plus 15. And boom, you've got 2 equations. From here, you can just use substitution or elimination to find the exact price of a pen and a pencil box. How about an age riddle? The first step is always the same. Define your variables. Let's say x is the dad's current age and y is the son's. The first clue gives you an equation about their ages today. The second clue gives you another one about where they'll be in 3 years. Once you've got those 2 equations written down, all you have to do is solve, and you'll know exactly how old they are right now. And for our last one, a distance puzzle. You're probably seeing the pattern by now, right? It always starts the same way. First, define what x and y are. Here, it's the speeds of the 2 cars. Then you take the 2 different situations they give you, cars going the same way, cars going opposite ways, and turn each one into an equation. Once that's done, you're on the home stretch to finding out how fast each car was going. So let's do a quick recap of your new puzzle-solving toolkit. You've got the map, that's your graphical method. You've got the shortcut, the substitution method. You've got the eraser, the elimination method. And of course, the secret code, that awesome ratio check. You're totally equipped now. But the biggest takeaway here isn't just about solving for x and y. It's about learning a powerful new way to think. It's a system for taking 2 different clues, 2 different pieces of information, and finding that one single point of truth where they connect. And that's a skill that'll help you solve all kinds of puzzles, way beyond the math classroom. So the real question is, now that you've mastered the tools, what puzzle are you going to solve next?